Hello. We're going to briefly revisit viscosity before we move on to talk about some additional differential equations. The reason is, even though we've talked about viscosity in the previous module, it's very, very important for the next couple of sets of equations we're going to look at. So we're just going to very briefly review some important things. First is Newton's law of viscosity. So Newton's law just says that the shear is the viscosity times what we call the shear rate. The shear rate is the same as the velocity gradient, or the change in velocity with a direction. So tau on the y face in the x direction is going to be equal to viscosity times the derivative of the x direction velocity with respect to y. And you can get one of these values of shear for all the different faces of your differential cube that we talked about in the previous set of slides. Now this is what we call a Newtonian fluid, where the viscosity is a constant. It does not depend on the shear rate or the velocity gradient. That gives us Newtonian fluid. We also have what we call non-Newtonian fluids, where the viscosity actually depends on the velocity gradient. And there's different types of behaviors, but in general, we should use the apparent viscosity for a particular condition in Newton's law of viscosity. Now in this case, the viscosity here is the dynamic viscosity that represents essentially the liquid friction. It's the resistance of a liquid to flow. Think about the thickness of a fluid. Water has a relatively low viscosity and it flows very readily. However, something like honey has a very high viscosity and it flows very slowly, and it's very hard to move through a system. The reason that the shear is important, that the viscosity is important, is because it tells us the shear stress on each of the different faces of our differential cube. And that's important for our momentum equation, because the momentum equation, remember, balances forces and inertia. That's basically Newton's second law, force equals mass times acceleration. So we need to be able to describe all of the forces acting on this fluid particle, and we're going to do that with Newton's law of viscosity and then our normal stresses basically due to pressure.